Here inside this real-world snow globe on the grounds of the University of Toronto, there's a state-of-the-art lab where nanoparticles are being created. By mixing lead and sulfur at a prescribed ratio and temperature, hundreds of millions of nanoparticles are instantaneously and somewhat magically synthesized. But what is nanotechnology? How revolutionary is it? And is it going to change how we see the world around us? For starters, the nano world is an invisible one. If you look at the distance between the ridges of skin on your fingertips, nanoparticles are 80,000 times smaller. These particles can only be glimpsed by the most powerful electron microscopes. This is the world of nano, where it's possible to shape matter and alter its basic properties. Scientists like Professor Ted Sargent at the University of Toronto believe nanotech is the only way to go. He sees a future where nanoparticles applied to solar cells transform the way we capture energy.
There's two aspects to these solar technologies that are incredibly exciting. The first is just raw performance to cost. The other thing about having a flexible solar cell or a paintable solar cell is that it just allows your imagination to go wild. Imagine if you could wear clothes that were solar energy harvesters and that would charge up the batteries of the mobile devices that you were carrying around. Imagine if you could create a sailboat whose sail was also a solar energy harvester and could charge up the battery on your sailboat. The imaginative possibilities that emerge when you start to make low-cost, flexible, and high-efficiency solar cells simultaneously are really limitless.
Solar energy has already caught the imagination of both environmentalists and entrepreneurs. But what if its efficiency could be dramatically enhanced? Here on the edge of the vast Arabian desert, King Abdullah is building at a furious pace, creating an intellectual oasis among the dunes. Total price tag, $12 billion. This is the King Abdullah University of Science and Technology, or KAUST for short. And look who's shown up here in Saudi Arabia. Professor Sargent and his solar nanotechnology have been beckoned to the land of easy oil. This country may be the largest exporter of oil in the world, but when you consider the amount of sunlight bombarding the desert floor every day, the potential for producing solar power here is simply astounding.
Solar to us is very important. Basically, we had the challenge from the chairman of KAUST board telling us that he wants Saudi Arabia in the future to export the same BTUs that we are exporting from fossil fuel in the form of solar energy. So I don't know how big that challenge is, but it's really a tall order challenge.
For Professor Sargent, the solution lies in designing a radically different solar collector using nanoparticles to maximize the sun's impact.
It's a bit like when, I guess it would have been in the 1950s, people wondered whether one could go to the moon. And it became clear that there's no physical impediment. There's no laws of physics that would prevent that from happening, and it became a technology challenge.
And it doesn't hurt that this technological challenge is fueled with a fantastic financial incentive.
Energy today is a $9 trillion industry. I can't think of a bigger sector of the economy. I mean, it's absolutely huge. It's something we almost don't notice because it's so much around us and we take it for granted. Does the eel show you like the elemental makeup of glycogen? Or?
In the world of nano, Professor Sargent is a big deal. More than just a visiting professor, he's a rock star in the fiercely competitive world of nanoscience. And he's here to sing the praises of his unique and potentially hugely profitable approach to harnessing a seemingly limitless force.
The sun's power reaching the Earth is really incredible. There's 10,000 times more solar power reaching the Earth every day than we use across all our energy habits. Another way to put the same idea is that as much sun hits the Earth in an hour as we consume in a year.
The key that Professor Sargent's solar nanotechnology holds is its potential to unlock energy across the sun's entire light spectrum.
One of the phenomena at the heart of nanotechnology is that we can shape matter. As a consequence, in my lab, when we make 3 different batches of nanoparticles, we can program them, each to be responsive to different slices of the sun's spectrum.
The initial solar cell prototypes that Ted is working on look like this: a glass square coated with thin layers of nanoparticles. Embed the cells with tiny electrodes, bombard them with laser beams, and you can measure both the wavelength and current, and also, more importantly, gauge the cell's capacity to absorb the energy from a crucial and as yet largely untapped source, the sun's invisible infrared rays.
And so it turns out that fully half of the sun's energy lies in the infrared frequencies and the other half in the visible. So my research acknowledges that we need to capture all of that energy if we're going to make an efficient solar cell.
Sargent is coy about his progress, but his experiments suggest that Nano could revolutionize the design and manufacture of solar cells, and that the next generation of solar power will look very different from the installations of today.
So the major differences in making quantum dot-based solar cells relative to existing approaches, the first is that we actually do work with individual nanometer-sized crystals, and they're individually packaged. So each one is in a position such that we can just coat it, spray it, if you like, paint it onto a backing.
Professor Sargent's City of the Future is one in which every building becomes its own power-generating station.
And then also, by virtue of their lower cost, you won't hesitate to deploy them across the entire surface of the building. In fact, if they're cheap enough, if there's a little bit of power to be had from the sides of the building, you might even put them there too.